This is a drone-based aerial survey of the area here in South Florida. We have here points, and these points are LIDAR points. These points are measured by the drone as it flies over the area at a fixed altitude. And these points can be referenced to something that is of a known elevation. Therefore, everything else that's measured would be accurately displayed at the correct elevation, say above ground level or above sea level. Here we have the home and the driveway and a tree. And here is the property line. Here we have another home. Here we have, actually this is an RV parked here. And over here at the side is another property with a blue car. Then we have behind the property here, we have trees. And these trees are 70, 80 feet high. And what we can do is modify or change the view, because these photographs that the drone is taken and measurements that the drone is taken has been converted into a model. So now we can spin the model and look at the area. And this is measured. When I say area, this is a 5-acre plot here, a 5-acre survey. And I can spin this 5 acres around and look at these properties, and you can see that these are roof lines that are spinning around here. Over here is a tiki hut, and this property back here is overgrown in vegetation. And as we spin around, and we're looking towards this south at the properties through the vegetation. And we can see here, these are called cloud points. They're the points measured by the drone, which are used to provide the model. And here we are. We just completed a 360-degree turn. Now we can look at the properties from more directly above. This is as the drone would have seen it, and now as we looked at it more directly above, you can see that this is a vehicle. This is a RV, and this is, I believe, another RV. And we can also take this data and we can do measurements. For example, I've already taken some measurements on the property. Here is a graphics in this cloud point display showing those measurements. And I'm just going to look at those measurements in the map form. This is the map that's been overlaid onto a satellite image. And here we have a high resolution measurements. And I can get rid of these annotations if you like. And we can change the map detail, or we can calibrate. Here's where we calibrate the elevations measured by the drone into a known elevation. And here we can crop our image. Say we want to bring in the borders and look at a smaller area, we can do that. And we can also look at the plant at an elevation model. Let's do this first. Here the elevations are shown in different colors. And we can also look at the same property and look at the plant health. And plant health is a function that the camera imaging can do, because the camera looks into the near infrared range, and using near infrared we can determine the chloral capacity of the plants. As the plants absorb sunlight through the photosynthesis, they produce chlorophyll, and the near infrared camera can measure that, and therefore can determine if these plants in a survey are healthy or unhealthy based on the amount of chlorophyll. You see here in red areas, this is on the ground, and I know from the aerial surveys that there is there's fewer grass here, and underneath this grass is sand. We see areas here that are green. Those are the trees that we saw in the higher elevations, and here are some trees, and here are some more trees, and there's plants on the west side of the property. We can also look at we've looked at the plant health and the elevation model. We can there's a terrain only elevation model, and we can also export all of this information, or using this button here we can share this information with a member of a group, and we can make it so that that member can view or that member can make inputs. Here I'm going to input my personal email address, and I will be invited through my personal email address to view the products from this aerial survey. I can also export all this information, and this is a fascinating part, I think, is that I can select many different ways to export this information. I can convert this into a 3D model object, and when I do that I want to get rid of these annotations. So first let me get rid of that annotations, and then let me export. And here I can create a 3D model. Now this resolution is not as great as it could be. This was created using 35 images, and those images were overlapped 50% from image to image. That can be enhanced by doubling up on the number of images produced. Here I can create a 3D model, and I can output that model out to, say, AutoCAD or as some animation program, and I can select here. Here's some existing exports that I've done already, but I can select here whether I want that to be a cloudpoint or I want that to be a model that can be imported into another program. Now I'm going to select the digital terrain model that I can have exported, and I can select the plant health or the ortho mosaic. Now the ortho mosaic is simply what that's saying is the ortho is the photographs that were combined into a mosaic that produced this aerial survey. And I can export that ortho mosaic into a JPEG or a PDF or a TIFF image, and I can have the map in a Mercator projection or a WG84 desktop, which is in meters. And there's also in this area, I tell you, I'm not quite sure what all of these different registrations are. The the NAD 83 2011 must be a survey, but I am simply guessing at that. But I can definitely select one of those and have it a single image or a tiled image, and I can have the resolution at 20 pixels per inch or 2 pixels per inch, and here I selected 1 pixel per inch, and I can export that. So it's currently being exported. So this is what I do now. I have a FAA drone license that allows me to commercially produce these surveys, and my services are for hire, so contact me and I'll give you a quote for whatever job that you need done.